Hi everyone, my name is Ajay Vaishest and I'm a market and credit risk consultant. In our previous videos, we covered basics of chi-square test and one of the application of chi-square test, that is test of independence. So till now we have understood chi-square test is used to determine if there exists a significant difference between expected distribution and the observed distribution. While the first application which we covered, that is test of independence, helps us to determine if there exists a significant difference between two variables. The variable should be in categorical in nature. That is, the variable should either be nominal or ordinal in nature. Now, and when it comes to the goodness of fit test of chi-square test, here we try to determine if there exists a significant distribution between observed and expected distribution. Now let us try to understand this with the help of an example. Let's say during 2011 Indian census was conducted, and for a particular town it was found that 20% of the population was below 18 years of age, whereas 25% of the population was between 18 to 35, and rest of the 55% of the population was 35 plus. Now let's say we in 2021 we picked 1,000 individuals randomly, and we found that out of those 1,000 individuals, 242 people were below 18 years of age, whereas 576 people were between the bucket of 18 to 35, and 182 people were above 35 years of age. Now, our task is to identify if the distribution of the population is as expected. Now, we already have the observed distribution, that is 242, 576 and 182 individuals lying into the three buckets of less than 18, 18 to 35 and 35 plus. Now, next step is to calculate expected number of individuals in each individual bucket. So this we would get by multiplying total number of individuals in the sample, that is 1,000 multiplied by the expected percentage of the population. So for the first bucket it would be 1,000 multiplied by 20%. Next would be 1,000 multiplied by 0.25, and the last one is 1,000 multiplied by 0.55. Now while multiplying we will get the expected distribution to be 200, 250, and the last one would be the 550 number of individuals lying in the bucket for 35 plus. Now we would conduct our test statistics in 7 steps. The first step would be to define our null hypothesis. In our case, our null hypothesis is that the observed distribution is similar to the expected distribution, and our alternative hypothesis would be that the observed distribution is significantly different from the expected distribution. Now the next step would be to define the number of or the degrees of freedom. Now this is calculated for goodness of fit, it is equal to the number of groups minus 1. In our case it is actually 3 minus 1 equal to 2. Now next is we would go and check the critical value based on the number of degrees freedom and the level of significance being decided. In our case, the degrees of freedom is equal to 2 and the level of significance we decided upon is equal to 0.05. Now, if we look into the table of chi-square distribution, we found that the critical value is 5.99. Now, if the calculated test statistics value would be greater than 5.99, then we would reject the null hypothesis. Otherwise, we would say that there does not exist a significant difference between observed and expected distribution, population distribution. Now, as we know that the formula to calculate test statistics in chi-square is the summation of the square difference between observed and expected value divided by the expected value. So if we put in all the numbers which we just calculated into the equation, we found that the critical value equal to 680, which is greater than 5.99. Thus, Based on the test conducted, we would conclude that there exists a significant difference between expected and observed distribution, and we would reject the null hypothesis. Thanks for watching, and please do like, share and comment. Thank you.